Okay, now we're gonna solve the exercise number A. What is the probability that when choosing a random student, his grade is lower than the theoretical mean? First of all, our mean is of 1000. This information was obtained with the results of exercise number 1. Then, our total number of students is 135. This would be our 100%. Then it says that choosing a random student whose grade is lower than the theoretical mean. The total number of students who has this grade is 13. This would be our x. Then we have to do a cross multiplication. We have to multiply 13 by 100, which gives us 1300. Then this we have to divide it by the total number of students, which is 135. This gives us 9.6. This would be the percentage.
Now we're going to solve the exercise B. What is the probability that when choosing a random student his grade is higher than the theoretical mean? Okay, first of all we have to keep in mind that the probability of the lower grade was from 9.6. So if we want to have the higher, we only have to subtract the total percentage minus 9.6. So that is the result, 90.40.
Letter C says that what is the probability to when choosing a random student his grade is higher than 1050 points? So there are 31 students and there are 123 different values, so that will be the 100%. So you have to get the probability of when choosing one of these, it will be higher than 1050. So this will be x. Now what you have to do is multiply this and when multiplying this, then you divide it by this. So it will be 22.96% of one student having that higher than 1050. Okay. Well, letter D says that what is the probability of choosing 5 random students whose individual grade is higher than 1149 points? So in this case, instead of putting 31, that is the number of all the students, you have to put 5, because you have just to choose 5 of the 31 students that there is. So the probability is next to the 5. That will be the x. Let's just wait for these things to focus. So 44 goes right here. That will be the 100%. So you have to do the same than the other thing around. So multiply it by this. Then you divide it. And that will give us 11.36%. Well, it seems that we are just too good in math that we also have sponsors. Mein Gott.
So in the problem E is asked, what is the probability of choosing 3 random students whose grade is higher than 1,200 points? So in all the data, only 15 of them got that higher score. So we take this one as 100%, and the probability to choose is 3 of them. So we make a rule of 3 and we get the score, we get the probability. And now in the exercise F says it has been decided that in each classroom only 15 students can take the test. How many different ways can the students be arranged if it has been decided to form only 3 lines? Well, in this case we just use the permutation formula. We just change we just put the numbers in his place, and this gives us 455. So that's the result.
Okay, so we continue with the exercise G. What is the probability that from the total candidates, 5 random students whose grade is higher than 1,149 points are chosen? In this case, the students whose grade is higher than this are 44. So we're gonna take this as our 100%. Then they ask for 5 random students. So again we have to do a cross multiplication, which is 5 multiplied by 100, and this gives us 500. Then this we have to divide it over the total number of students. In this case is 44, and this gives us as a result 11.36%.
Letter H. According to the percentage of students who pass the test, what is your opinion regarding this institution? Okay, in my opinion, this institution is pretty cool because the teachers are excellent, seeing the grades of the students, because it's higher the percentage of students that his grade is higher than the theoretical mean than the students that his grade is lower than the theoretical mean. So you can realize that in this institution the teachers give essential information to the students, so the students also are because they pay attention and all of that. So that is my opinion.
So finally, exercise number I. Do you think probability will help in the decision making, and why? Well, I will think that yes, because having data that come close to the final result is very helpful, because it gives us a more realistic perspective on the dynamics that are taking place, and the results are more close to the real ones. So we have the option to omit all kinds of exaggerations or unsupported estimates.